Okay, well, um, been meaning to do a video on this new machine build. Basically, what we have here is a standalone seat and guide machine. Money involved is very little, obviously, because that's how I roll. But it's kind of one of them things where I'd had all this stuff, and then it just kind of dawned on me one day. I just thought, started putting some of the stuff that I've had in the shed kind of like together in my head. And it just kind of happened. And I'm still working on it actually. I have a few more components that need to arrive, and then I could probably finish it and make the first cut. And then when I say make the first cut, essentially this machine will do cut in your. It's set up like a SERDI style machine, so it will cut in it has a carbide cutters that are have fixed angles on them, certain widths, things of that nature. For many years, I just realized today it's like coming up on 27 years that I've been messing around with heads. I'd always wanted a lot of different machines, but just could never afford them. I guess I could never justify. I mean, granted, if you had good clientele and basically to keep the machines running, then the purchase is justified. So in my case, you could have one year that's just crazy busy, and then all of a sudden, you'll have a year or two that just kind of get nothing. I mean, you'll get some, work, but it doesn't really justify a lot of the machines just kind of sitting at idle. I've been in this shop for probably, think it was roughly about 15 years now. I've built this thing from the shop and everything in it, like from ground up. So when somebody knocks it, it kind of sucks because you're constantly busy. So getting back to the video, I tend to ramble. So getting back to the video, like I said, I just wanted to kind of cover this. The only problem with it is I've waited kind of too long to start covering it. I wanted to do it like my mill build. Here, I'm going to shut this heater up. My mill build over here. Years ago, I've got several different videos on it's a round column that I converted to CNC that has slung a ton of chips, and thinking about upgrading it with some stuff and cleaning up the wiring and such. So that's another story, but yeah, I want to cover this before I get too far, but I've already the problem with that is I'm already somewhat done. So essentially what happened was, it started out as this was a Wilton drill press that had I think it's 3.5 or 4-inch column. I basically was over in an area of my city and picking up some stuff parts wise, and kind of seeing the thing in the back yard of somebody over there, and basically this thing was sitting in somebody's backyard, basically all rusted away. And the problem it wasn't a problem. Well, I'd stopped, had my son with me, and was kind of funny because he rolled his eyes and said, "What did you see now?" And so I parked and then went up to the door, knocked on the door, and I said, "Hey, looking to get rid of that drill press." The guy in the background, his wife answers, and she asks him, and he says, "Take it, get it out of here." So, and it was cold. It was really cold that day, and this thing was, I think, like right around 300 pounds. So, it was kind of a manhandling to get it into the back of the truck. So, I had that here for probably a year and a half. Well, it was about a year, and I didn't really know what I was going to do. I thought I was going to restore it. But in theory, it's like, okay, I restore it, then what? I mean, you have a machine. I have a drill press that I've had here for 25 years, and it's, it does everything that a drill press needs to do. So, you think to yourself, okay, I restore that, and it'll be a pretty stout, because if you bought this drill press, I mean, it's a $1,500 drill press. Due to the fact that, the bed that was on it, before I cut the column off, I'll get to all that. Before all that, the base and then the bed, it had a tilt bed. I think the foot pattern on that was 20 by 20 or something. I don't know. Something to that effect. So, what has happened over the course of, I think, I don't know, kind of lose track of time, we start working on this stuff. I think I've been working on this machine for, let's see, I'm going to say 2.5 months maybe. When I got the machine, I didn't have this in here. Any of that stuff. I had the cover up here. That stuff is left over from when I CNC'd that mill. That's the handle. So, had those in the drawer. So basically what I had done, I kind of done some R&D and started looking at it. Well, so the base was at the very bottom, and you have, your bottom of your drill press. So then I just cut that whole tube. I mean, this thing was just literally just a solid rest. So I had to disassemble it, dissect everything, get everything to work. Basically restore every component on it to make it work. That's the motor that came off of it, which is sitting there. The reverse didn't work, and my goal was, if I'm going to build a machine like this, I wanted reverse in the sense that if I'm going to drill and tap and for rocker studs and things of that nature, I wanted to have reverse, and I'll get to that as well. So then I realized that even if you follow the wire diagram in there, that's a reversible motor, the one that was on the machine, but that for whatever reason it wouldn't work. So I just kind of put that aside. This is the 2 horsepower motor off of the mill after I CNC'd it. So yeah, I wanted to, so I had that component, and I started looking at jigs online. My main goal was 20, when I was in my 20s, I worked at an automotive machine shop, and we had a Winona Van Norman machine, which I grown to, very fond of, in the sense that it was just very user-friendly. In user-friendly meaning that the jig that holds the cylinder head was airflow. Because, all the tooling that's on cylinder head machining is all piloted. Not all. I would say probably 98% of the tooling is all pilot. You use a pilot of some sort to keep it, concentric with whatever hole that you're either machining or, restoring or something. I'm losing my words right now, but because there's so much I want to cover on this that I'm afraid that the video is going to get too long, but that's my own fault because I've waited too long to cover this build. So I had scoured and scoured the internet for like an air float table, a standalone build, but all I was coming up with was everything was done on this jig. Was basically, I kind of copied some stuff on some of the stuff that I seen online, but I kind of did put my own twist on some things and change things that I thought were better and more user friendly. But everything that I seen was, this jig itself was bolted to a Bridgeport. Well, I didn't really like that idea just because, you go with what you know, and so basically, in my head, when you're dealing with, if you have a bolted solid jig that has a cylinder head, in order to feel it in a sense, I would rather have, like if you're doing valve guides and doing seats and stuff like that, you would want to have center to center in order to get a feel of it. So, with the Winona Van Norman stuff, it wasn't set up that way. It was set up in the sense that, you put a cylinder head, any given cylinder head in there, and then you articulate the jig to get basically the valve guide or whatever component or whatever hole that you're machining plumb with the spindle. That's the end goal. And then once you do that, then if it's on that same plane, for example, like a big block Chevy is a canted valve head, like your 460 stuff, Cleveland, things like that. You're going to have canted valve heads, so you're going to have different angles of plumb and level on intake to exhaust. So you have to have a jig that'll articulate it in that such a way that, most everything that you machine, like small block Chevy, I'm into Oldsmobile, most any cylinder head is going to be straight across. So once you plumb that valve guide to your spindle chuck, then it's nice, because once that happens, if you can in theory achieve this table and move on its own and have basically, on any given cylinder head, I'm going to have with the jig included in the cylinder head, I'm approaching 150 pounds plus. So it's kind of nice if you can have it set up in such a way that much weight, you can actually hit a pedal. And I'll get to this. I think this video is going to be pretty long, unfortunately. You can have a pedal that once you apply air pressure to, that whole fixturing and everything will float to basically, once you get it to the next valve guide, you'll run this down and get it close to the hole, the valve guide, and then you'll get it, pull the Z down inside the valve guide, and then you air float that, and it's basically a self-leveling, self-centering, I guess is the better word. It's a self-centering setup. So once you float that, then you're ready to go for the next one. And then you let your foot off the pedal, and then that 150 pounds is sitting there, and you're relying on the weight of that jig and everything to basically retain your position, which is really no problem because you've got a pilot. So if anything moves, it's not going to move very far because you're driving off the pilot, remember? So yeah, things like that if you could set the machine up to be like that, which is what was my goal, was, and that's essentially what I've achieved. So what had happened over course of, like I said, 2.5 months, I I had a metal bench or a metal rolling cart. This is one of them Harbor Freight detail, or I call it. I was using it for my detail box to detail cars, buff and wax and things like that. But whatever. But kind of changed some stuff around. Took that out of the frame. Basically put that in there to house all my tooling. And then I originally started with this very bottom of the JIG is aluminum. It's a 1-inch aluminum plate. Well, I'd had a full plate 1-inch up here as well, and it was pretty straight. It's pretty level. I started putting a straight edge on it, and then you could slide feeler gauges under there, and it was distorted. And then another thing is, once you have that, it's distorted in the sense that when I was, asking different vendors of machines and things like that because I used the machine for several years and never really paid attention to what made the airflow work. Didn't know if it was, this whole JIG is, I've gone through a lot of R&D on my own just to kind of figure out what works. I could dissect all that and tell you, this has got 2 different plates under it. There's a gasket in there. There's a 100 thousandths chamber that I CNC'd basically to plumb that in. And then I put like 16 100 thousandths holes on 1 inch over like 10-inch square. And thought that was going to be the answer. Well, it basically failed in so many ways. It was ridiculous because of a lot of things. But at the end of the day, make a long story short, or long story longer, I guess you could say, all that R&D kind of worked out for me because all I ended up, what it boiled down to was one hole right in the center, and the key component to making that work is flatness. So I had come across where I work as a date for employment for a day job. I'm exposed to a lot of different materials that is very expensive, I guess you could say. A lot of components, materials. So we had a machine that we were scrapping. This is a 1-inch steel plate. Now it's been surface ground. The whole plate has been surface ground. I can literally put a 24-inch straight edge under there, and I cannot get a thousandths feeler gauge under there. Once I implemented that plate, and then knowing full well that even the aluminum under here was within a couple thousandths as far as being flat. As soon as I hit that foot pedal and I had all that weight on there, this thing just floated. I was so excited. I could not believe what I was seeing, honestly. So that being said, I think I've kind of caught you up to... Oh, and another thing, too, is when I got this whole structure here, this drill press, it was what they call... excuse me. What I seen was it was sucked because it had no pulleys on it. So the unfortunate thing was, so I had to... I have pretty good amount of cost into this. It's a proprietary taper on here. Pulley. I bought that, and then it's a reverse thread nut up here. So I bought that. But looking at the pulleys, the idler pulley and the drive pulley, they're kind of generic in the sense that they're not really a specific size, and I can machine, a bushing or a machine. So I'm waiting on another pulley so I can implement the center idler pulley, because what I'm trying to do is achieve 150 RPM on the spindle. And another thing that I added was, instead of having a drill truck for some of the stuff, this is I think it's a Morse Taper 3, I think it was. I had to look, but pretty sure that's what it was. So I got a collet set up that's Morse Taper 3 to ER32 collet. So where we're at now is, I think I've kind of caught you up a majority. I'd like to get into more details to what I got, but like I said, I've got, you know, lots of different tooling that I've built, stuff that I've had over the years that I use. Here's your collets. Here's all the, I bought these, are kind of nice for that setup. I'll get into that in a bit. A lot of the wing nuts that I machine, different, you know, components that are, you know, proprietary to this machine. Yeah, lots of different guided drills. I have the seat. This setup is meant to do on its own, basically, with no fixturing. It has its own fixturing. It basically bolts to the cylinder head to cut a hard seat pocket in. So yeah, my hope is to use all the tooling, but just kind of implement it to the machine. I'm going to pause the video real quick. I got to go do an errand, and I'll be right back. Okay, I'm back. Kind of like that pause feature. That was kind of nice. Okay, so where was I? Showed you the tooling. So basically, the jig consists of I have 1-inch steel plates here. These are V blocks. The key component to this whole fixturing is this is an 1 3/4 inch chrome hydraulic rod, and then I have a machined plate, been in surface grinder. Now I've done the R&D, and I've done most stuff that I probably will do, and if I have to add something to the ensemble, if you will. You don't know if I can see it there. Yeah, so I have everything kind of marked. It's like as far as what holds what. This end down here is kind of like the master end, if I guess you could say. And I've got it set up to where everything sits on this, like your valve cover rails, sits on this chrome rod. So that way everything is basically, you know, starts out pretty darn plumb with the table and the spindle. I've got it set up to where, you know, a guy can swivel this over out of the way. I'm going to put some more cord on it so I can swivel it the other way, get it out, you know, set up cutters and things like that. Started building like a tooling little hanger, I guess. One thing that was nice about this that made it possible, was just amazing to me, was this cutter. These cutter components are very proprietary, and they're so expensive. To give you an idea, from like say Goodson, any, you know, mail order machine, automotive machine place, there's 2 components right here. Most everywhere you go, you're looking at $250 right here. There's no insert there yet either. The inserts are about $55 a piece, depending on what profile you want. Well, I scoured and scoured and scoured, and I'm not going to give the name of the vendor because I feel that it's going to be short-lived as far as the components being so cheap. But I've got these 2 components here, was $46. So I've saved over $200. And yeah, it's basically exactly like a Surdy or a Rottler type of deal. More so a Surdy. And then I also built the setup fixture that you put your valve in there, and then you mark where you want your seat, and then you transfer that to your carbide insert, and then that's where you're at right here. With this insert here, you cut those angles in. So basically what I've got it set up as is like I said, what I'm waiting on is the pulleys, and then I also I set it up for, like I said, the tapping deal. I've got a switch here that is wired in such a way that you have to wait for the motor to, that clutch to disengage. It's capacitive start, but once you tap, you can tap a slow RPM and then stop it, and then it'll stop. It'll kind of coast a little bit, but then you could back it back out and reverse the motor. I'm not going to show you that. It forward and reverse. That's it. So that was kind of a nice feature. Then I also added a tack. I'll just kind of, yeah. At least it's reflected. Yeah. So that's kind of cool. I wanted that just so I could verify RPM on my own. So I have yet to do a little bit better on this here. I'm going to build a over on this side here. I'm going to build use an old set of digital calipers. It'll be a depth gauge. But like I said, I'm getting these are all set up in such a way that once you bolt the cylinder head on there, everything bolts to the exhaust flange. I've still got 2 standoffs to build. This works for most stuff here, but when I'm doing like a cannon valve, I need a really short one. So I think I'm going to build even a shorter one than this, and essentially all this is just guts from a C-clamp. So that I turned down that cast and then welded my little, I wanted it, since if you're doing I wanted this articulate head here like that, because if you're doing a cannon valve head and this essentially sits under your valve cover rail, it's not flat, so it needs the articulation there to follow that valve cover rail in whatever angle that you have it. Like I said, pilots, but I got it set up to where I had to machine all this stuff. This just, once you loosen this, these are just kind of snug down, and then there's I think it's about 100 thou gap up here, so that way when you loosen this, it'll pivot, and then there's only the front adjustment to tighten it down. But I still have to make, because I got it set up to where, say, a big block Chevy, one of the exhaust bolts sits on top of the jig. So even while you do that, I still want some adjustment. So what I'm going to do is I have some micrometers that I'm going to machine there'll be a series of bolts up here that you unbolted, or I might just implement several up here, and it'll be basically a wide washer that will straddle the stud. It'll have a pivot point on the mic. You know, it'll be kind of like this. It'll still swivel on there, but it'll raise that stud up and down. And then once I have where I want, and then it'll be in such a way that when I tighten it down, that'll be out of the way. Or I could take it off, or, you know, things like that. So, still fine tuning that. Kind of a minor setback on that because it's pretty true the way it is. I mean, it's, yeah. And then built this here. I'm thinking about welding it to that. I don't know yet. But I built it in such a way that I could put it anywhere I want. Essentially all that is just a, you know, a leverage bar to where if you have your cylinder head on there, you could loosen those in such a way you have a little bit of drag, and then I could lift, or, you know, allow the cylinder head to drop via this handle. Yeah, so here's the cool feature, is that's the air pedal. I'm going to try to get a good view here because it'll just float. Yeah. So I'm going to bring her back up here. So the jig, to give you an idea, the jig itself, I think is I think what we decided. I haven't weighed it yet because I got stuff to add to it. But the jig, I think, is approaching 100 pounds itself. So I got it set up in a way, and it's like, it's not completely level, but I'll get it there, the machine itself. So it just follows the machine, you know. So this steel top was basically the key to all of that. So, like I said, I hit the foot pedal and watch. So, as you can about imagine, to get that kind of feature and that kind of result, because it basically mirrors the machine that I ran, 20 some years ago. To be able to achieve that on just everything home built, I mean, I was so excited that night that I achieved that. So I'm still adding to the machine, and I kind of wanted to, like I said, I got lots of tooling showing up still. I've got a lot of spot face cutters that are piloted, have to machine pilots. Everything, it's kind of just a few sizes. Like in my case, I'll do LS, LS, Oldsmobile, big block Chevy, small block Chevy, some small block Ford stuff, some Cleveland stuff, big block Ford. So yeah, everything's kind of proprietary to those holes, and then you just machine the holes that you need, basically, and then go from there. So the way I'm looking at it is, there's no reason, like, I got these from a company, it was Zorro or something like that. I got a 5-pack for, it was $30, I think, 5 of them, and that was exactly the amount I needed, and I had one left over. Granted, these were half 13, but then I machined a sleeve. I actually helicoed these, but I think later on I'm gonna machine a sleeve and bore that out and just put a 3/8 sleeve in there, because it threw the 3/8 16 in the back. But then I have to do a proprietary stud for an LS for the 8mm to 3/8 to kind of keep that the same. It'll just be different set of studs to slip through. So yeah, pretty cool deal. Like I said, here's the pilots that are